Hey everyone! In this video we're going to be looking at how to identify standard and reference angles. So I'm going to go ahead and put up a little angle here just at the side so that we can look at some of the parts at it, and then we'll put one on the axis. So I've drawn two little arms, and in between them I'm going to put theta. And the two arms that we drew, one of them has to be the initial arm, the first one that you drew, and the other one is called the terminal arm. And in between the initial arm and the terminal arm is theta, our angle, which is found by going counterclockwise from the initial arm. So we draw an initial arm, a terminal arm, and if you go counterclockwise in between them, that's theta, our angle. I'm going to go ahead and put one over here on the axis so that we can see all of the criteria for a standard angle. We'll see if I can draw this good. I'm not much of an artist, but we'll see how this goes. Oh, that worked. Huzzah! Okay. So I went ahead and got a standard angle here. And there's some criteria that specifies that this is a standard angle and not just some angle that we drew. And here's the rules. Rules for standard angles. And as long as you check these, you're never going to get this wrong. Number 1. Initial and terminal arms begin at the origin. You cannot just begin your angle anywhere you want in order for it to be a standard angle. It has to begin at the origin. And number 2, the initial arm, that first one that we drew coming from the origin, must follow. The initial arm must follow the positive x-axis. We can check to see if those two things are true. If that is the case, we have a standard angle. So let's go and look at some examples, and then we'll see what reference angles are after that. So we'll move this up, and I'm just going to go ahead and put another axis here. And we're going to put a standard angle on it. We're going to know it's a standard angle because our initial arm right here began at the origin and went along the positive x-axis. Our terminal arm begins at the origin. Does not matter where that goes. We can go in any direction we want, but when we label theta, our unknown, it must be counterclockwise from this initial arm. So we know that our theta is right there. This is a standard angle. Now we could estimate this standard angle by knowing that straight to the right is 0 degrees. So if these two lines were exactly on top of each other, we would say that we didn't rotate anywhere. It was a 0 degree rotation. If the terminal arm goes straight up, that's 90 degrees. Terminal arm to the left, 180 degrees. Terminal arm straight down, 270 degrees. And if the terminal arm somehow gets all the way back around, that's a 360 degree rotation. So technically we could have like a 359 angle if it was like really close to the axis here. And that's all right. If you were asked to estimate this standard angle, would you be able to do that? You would look at this and say, well, straight up is 90 and straight over is 185 or 180. This is kind of in the middle. Is this 135 degrees? And your teacher cheers and your parents cheer and everyone cheers because that's a really good guess. It's probably about 135 degrees. Let's do another example, and then in this one we're going to introduce what a reference angle is. So we are going to draw 3 different standard angles here, and the 3 different standard angles that we are going to draw are going to be approximately 60 degrees, we are going to try and approximate 160 degrees. We'll start with that. So again, we draw a little axis, and we'll draw one for each of these. And we're going to try and estimate where a 60-degree standard angle would go. We know where we have to start. The initial arm has to start at the origin and go right along the x-axis. We know that if we went all the way to the top, that will be 90 degrees. 60 degrees is about 2/3 of the way. So we probably end up with something that goes up like this. Straight diagonal would have been 45 degrees. We can feel fairly comfortable that this is about a 60-degree guess. Let's do the same thing for 160 degrees. In 160 degrees, we're going to again start at the origin, move right along the x-axis. Beautiful little initial arm there. We want our terminal arm. This would be 0. Straight up will be 90. Straight to the left would be 180. We don't want to go that far, so let's try and go a little bit up of 180. And we can probably safely assume that that's a happy estimate for 160 degrees without going and grabbing protractors and actually measuring it out. What we need now is a reference angle. A reference angle is the shortest, the smallest angle between the terminal arm and the x-axis. So we're going to get reference angles for these two up above, and then we'll see how we're feeling there. In this first example, here's our terminal arm. I'm just going to label it T here, just for sake. It doesn't really matter. We need to figure out what's the fastest way to get from this terminal arm to the x-axis. We could go this way and come down to the x-axis, or we could go all the way around, keep rotating until we get to 180 degrees. We need to decide which way is shorter. In this case, it's going to be the 60 degrees. If we had to continue rotating the other way, using your straight angle rule and knowing that a straight angle line is 180 degrees, this path would have been 120 degrees. That is definitely not smaller than 60 degrees. So the shortest, the smallest angle that can be made between the terminal arm and the x-axis in this case is 60 degrees. Let's look at our second example. In this example, here's our terminal arm. I'm just going to label T so everyone can see that. There are two options for us to rotate to get to the x-axis. This is 160 degrees. That means our standard angle here is 160 degrees. So we have a choice. Oh, I hope that you're just like smirking and you already know the answer. We could go back 160 degrees to get to the x-axis, or, and just hear me out, we could continue rotating a little bit more to reach the x-axis. How much more? Well, if we've already rotated 160 degrees, this would be 20 degrees more, which is in fact the shortest, it's the smallest angle between this terminal arm and the x-axis. So when someone is asking you for standard angle, that's this total rotation from 0 degrees counterclockwise all the way around. When you're being asked for the reference angle, you're simply looking for the shortest, the smallest angle between this terminal arm and the x-axis. And we can even do it in the other quadrants here. Do one last example so you can see what this looks like. We're going to go ahead and do one for 220 degrees. 220 degrees. So we're going to estimate that. Our standard angle will begin at the origin, go straight out to the x-axis. We want to estimate 220 degrees. We know that this is 0, this is 90, this is 180, this is 270. We're not that far, we're only 220. So we would rotate around. We know it's past 180. It's not quite halfway to 270, so maybe we put it like this. Now that's just an estimate, and we're okay with that. But unlike the examples up above, in order to get back to the x-axis, we wouldn't have to rotate all the way back around the full 220. This time, we can rotate up here to get to the x-axis, or continue rotating this way. Because this standard angle is 220 degrees, we can use a little bit of math and figure out that 220 degrees is 40 degrees past 180. If we were to go the other way, using our straight angle rule, we would have to travel 140 degrees. Which way is the shortest path to rotate this terminal arm back to the x-axis? We can rotate it back up 40 degrees, or continue rotating it around an additional 140. I'm hoping that everyone watching this would be like, it's obviously the 40 degrees. And that's how we do our reference angles. I hope that this was helpful for you. Thank you very much, and I'll be looking forward to seeing you next time.